Dear students, in this class, we are learning about structure program. This is an exercise number 9 for you. So here we are supposed to write a C program to store and display information of a student using structure. Before getting into the concept of structure, let us discuss about the basics of structure, and then slowly we will move to the in-depth idea about the structure, and we can come to the example program of storing the student's information using structure. So initially, the structure is basically is a collection of elements. Okay, so as per the definition given here, it is used for handling group of logically related data items. In this example, the student name, roll number, and the marks are logically related data items which are most related to students. Okay, so likewise, we are able to store collection of data items using structure. So in terms of array, we will be able to store the same collection of the data, but all those data will be of the same data type. But in structure, we can have a collection of data of different data type. Okay, so another one example given here is real part and the complex part of complex number. Suppose if you are dealing with some complex number, obviously we are able to represent those complex number in the form of real part as well as the imaginary part. So that likewise, this kind of complex number representation also can be part of this structure. As with this structure, we can represent both the real part as well as the complex part. So this structure is very much helpful in organizing complex data. So in more meaningful way, we are able to store the data in a more meaningful way. The individual structure elements are called members of the structure. This is very, very important one. The individual elements of the structures are obviously called as the members of the structure. Then how we are able to define the structure? A structure can be defined using a keyword called struct. Struct is a keyword. Then we will be having the name of the structure. So here the name of the structure is tag. Here tag is the name of the structure, and within the curly braces, we will be having various number of members of the structure. So all the members are more related to the structure name, what we have mentioned here. So here structure is the C keyword, tag is the name of the structure, and member 1, member 2 are individual member declarations. So likewise, we can have any number of members that can be declared. So this is simple definition. Then these individual members, what we are declaring here as member 1, member 2, member 3, or can be variables, pointers, or arrays, and or other data structures, or other structures also can be considered as the member of one structure. So the member names within a particular structure must be distinct from one another. That means the member name should be different from one another. The member name can be the same as the name of the variable, okay, but the variable is basically defined outside of the structure. So once the structure has been defined, the individual structure type variable can be declared. So how we are able to declare the variable is struct, then structure name, then variable 1, variable 2, variable 3. So likewise, we can create multiple variables as per the demand. Okay, so the structure what we are supposed to follow here is struct. Okay, struct should be the key is the keyword, it must be included, and tag is the structure name, and rest of the others are the variable 1, variable 2, up to variable n, whatever it may be, we can create. Okay, then structure definition. So in this example, we have created a structure called student. So this particular structure has the members as like student name, roll number, total marks, and date of birth, DOB. So these are the structure members of the structure student. So how we are able to access this structure member is with the help of structure variable. So structure variables can be accessed with the help of variables can be accessed with the can be created as like stuck with the then structure name, then variable name 1, variable name 2, variable name 3, as like this. Okay, so here the struct student is the new data type. Basically, it is a data type here. So for this particular data type, we are creating 3 variables as A1, A2, and A3. Then here it is possible to combine the declaration of the structure with the structure variables. So both the declaration, this is the structure declaration where the structure name is tag, and here we are declaring the variables as variable 1, variable 2, variable n, as like this. So comparing to our previous declaration, here in this current way of combined form of declaration, we are not using the separate statement for creating the variable or declaring the variable with the keyword struct. As a combined form of structured definition, we are creating the variables as like this. Okay, so this in the above example, we are declaring 3 variables of type struct and struct tag. Okay, so in this one, tag is optional, so it is not necessary to give the structure name. Okay, then accessing structure. The members of the structure are processed individually as a separate entities. Okay, so each member is a separate variable. Structure members can be accessed by using the dot operator with the syntax as like what we can variable name dot member name. So we can access the members by variable name dot member name. By the way, we are able to access the structure members. So where variable refers to the name of the structure type. Okay, then name of the structure type variable. Member refers to the name of the member within the structure. So we are having the variable as well as the members. So in order to access the members with the help of the structure or the with the help of the syntax like variable name dot member name, we are able to access the members of the structure. Okay, let us come to this example where we are creating a structure. Here the structure name is complex. So for this particular structure, we are creating 2 members. Okay, so real as well as the complex, CMPL. PLEX, these 2 are the members of the structure. Then we are creating another one variable. So we are creating the variable of the structure. So here A comma B comma C are the variables of the structures. Okay, so we are creating the structure by defining the structure with its name as complex, with the member like real, complex, etc., and the variables as A, B, and C. So now we are trying to read the values for the members with the help of structure variable. As per the syntax, we are supposed to read the variables. We are supposed to read the value for the variables with the structure like variable name dot member name, right? So here A is the variable name and its member name is real. Similarly, here A dot complex, where A is the variable name and complex is the member name. So at the bottom here we are having B as the variable name and B dot real is the member name. So likewise, we are able to access the value of the members with the help of the variable with the dot operator, that is variable name dot member name. Then we can do the computation also with the help of this structure like variable name dot member name. So variable name C dot real equal to A dot real plus B dot real. That means we are accessing the member real through variable A and variable B. So we are able to create, we are maintaining the real and complex part for 3 different entities, A, B, C. Okay, so that we can access those three different entities members with the reference of variable name dot member name, and we can do the computation also as like this. So similarly, the complex here the computation is computed as like with C dot complex equal to A dot complex plus what's that B dot complex. Then we are printing. So while printing also we are supposed to follow the same format, that is variable name dot member name. So from this study, it is understood that each and every representation of the structure member can be done with the help of the referencing structure variables. Okay, so this is what the basics of the complex basics and the basics of structure with an example complex number addition. So here we are having various other functions related to structure variables. So the operations that we can have here is comparison. That is, sorry, comparison in the sense, it is not a comparison, it is basically an assigning assignment. Okay, so structure variable can be directly assigned to another structure variable. So array cannot be assigned as like this, but structure can be assigned as like our normal variable. Okay, so here the A1 and the A2, A1 is one structure variable. This variable is assigned to another structure. A2 is another structure variable. A2 is assigned to A1. So all the due to this assignment, all the individual members also get assigned. Okay, then two structure variables cannot be compared. So here the comparison is not possible, whether it is greater than, less than, or equal to. So such kind of comparison is not possible in structure. Okay, then we are moving to the next important title, that is array of structures. Array of structures is very important concept. So here, once a structure has been defined, we can declare an array of structure also. Okay, so how the array of the structure can be declared means, we as like the example given here, struct is a keyword, then student is the structure name, then here we can have the class of 50. So class of 50, here it is an array of size 50. Okay, array of size 50. This array comes with the structure name called the student. Then the individual members can be accessed by as like our normal variable. Here we are representing the array with its index. Class of I dot name means if it is class 5, then we can have class of I 5 dot roll number, then class of 6 dot roll number 7. So since there are 50 classes, we can have an index right from 0 to 49. So with the help of index as a class, that is array name, within a bracket we can specify its index, and we can have the access of the variable name as like this. Okay, so this is the way we can use the arrays structures with arrays. Okay, then arrays within structure. So arrays within structure is little different, that within a structure or inside the structure we are creating an array. So here character name of 30 is the array. This array is created within a structure called student. Student is the name of the structure. So we are creating as like this. Okay, then inside this structure student, we are having another variables, other variables like roll number, name, roll number, then marks, and date of birth as like that. Here we have the structure variables as like A1, A2, A3 are the structure variables, and the array elements within the structure can be accessed by the format like variable name. This is variable name dot, then member name. Member is mark. Here we have taken the member array member as marks of 5. So if it is mark 2, second mark or the mark at the index 2 is to be read means then we need to use the syntax as variable name dot member name. Similarly here also variable name dot member name. So this is the way we can access the array members within a structure as like our normal variables. Then a structure initialization. So structure variables next. This is also very important concept we are supposed to remember. It may be initialized following similar rules of the array. So basically, the array will be initialized within by putting the elements in a curly braces, right? So here also the elements are placed inside the curly braces, okay, and they are initialized as like this here. That is struct, then structure name, structure name, then array name. A, we are initializing it with the curly braces as like our normal array initialization. Okay, so here in this example we have taken as so since we have assigned as a equal to 1.0 comma 2.0, so the assignment would be taken as like this: as dot real part is 1.0, a dot imaginary part equal to 2.0. Similarly, the variable b is are assigned like minus 3.0 and 4.0. b dot real part will take minus 3.0 and the imaginary part will take value as b dot image equal to 4.0. Okay, so likewise we can initialize the structure variables as like our initialization in normal array. Okay, same rule we will be following here. Okay, then parameter passing in a function. So structure variables can be passed as a parameter like other variables. So look at this particular example. Here we have taken a function called swap. So for this particular function, the structure variable, that is structure name, complex is the structure name, A is the variable name. Similarly, we are having passing another variable where struct is a keyword and the complex is the structure name and B is the variable name. So we can we can have the structure variable as a member of the functions too by using structure name, then variable name we are declaring, then we are manipulating as like our normal variable. So the parameter structure variables can also be passed as a parameter to a function. Then if we are passing the structure as a function, we are obviously able to returning the structure variables from the function. So how we are able to returning it is as like our normal function where we return some values after computation. We can return the structure variables also as like our normal variable. So in this example, here where we are creating a structure called complex and the structure method called add. So where the structure name is complex, the method name is add, and for this particular method we are passing two parameters. One is A and another part is B, that is structure name, then structure name, then variable name, structure name and variable name. So here A is a structure name where A is the variable name we are passing to this structure, and A is the variable name we are passing to this structure, and similarly B also a variable name we are passing to this structure. Okay, so likewise, we are declaring one more structure variable called temp. Okay, so this variable is used for manipulation as like variable name dot member name. So variable name is temp dot member name is real equal to A dot real plus B dot real. Similarly, variable name temp dot member name is image, then A dot image and B dot imaginary. So that is what I presented. Then we are after computation simply we are returning the temp value. Okay, so here the temp is the structure variable created within a function called add. Okay, so direct arithmetic operations are basically not possible, but indirectly we can do the arithmetic operation with the help of structure variables creation. Okay, so this is the explanation for returning structures. Then defining new data type. So we can define a new data type where the structure can be invoked with this new data type, but it is not specifically for the data type called type def. So it can be used for any kind of applications. So here, with the help of the type def, we are able to create our own data type. So we have standard data types like integer, float, um, character, double, as like that. But here, with the help of type def, we can create our own data type. So look at this syntax where type def, this is the keyword used for creating user defined data type. Then struct is the keyword, then new data, new type. Then within that structure, we are creating variable 1, member variable 2, up to member variable n we can create. And we have a variable, we are creating a variable called m type. Okay, so in this example or the syntax given, my type is the name of the new data type. This is the name of the new data type. It is also called an alias for new data type. So writing tag name new data type is optional. It is not mandatory. Naming follows the rules of variable naming. Obviously, as like other variable naming rules will be applicable here also. So let us look at an example for type def. We have used a keyword type def as the prefix of the structure called here we haven't mentioned the name here, but we are using the, in order to represent the structure, we should use the struct keyword at least. Then within the structure, we are creating the members like real and imaginary, and we have created one variable called complex. So here, here in our previous example, and all, we used to have refer these members or the names outside the structure variable as what's that structure variables. Outside the structure as structure variable. Here, since due to this type def, so type def here it is considered as the data type. Okay, so here complex is the data type. Now we can declare and use variables of this data type. As like our normal data type like integer, we can prefix the structure structured data type named complex here for declaring new variables. So here we are declaring 3 variables such as variable A, variable B, and variable C. Okay, so this is the way we are able to use the structure type def keyword for creating user defined data type. Okay, and then it is not restricted. That is what I told you already. Not restricted to just structure. It can be defined new types from existing types. Okay, so type def int integer, so defines new type named integer from the known type int. Okay. Then now define variables of type integer, which will have all properties of the int data type. So here we have declared for int integer. So usually for integer we will be representing we will be using the standard data type, right, int. But here in order to use the, or in order to implement the type def nature, we are creating our own data type with the name of integer by prefixing type def, then standard data type, then integer. So integer now the name integer will acts like an individual data type. Then based on that, we are able to create various variables like our normal variable creation. So here there is no data type with bold letters like integer. Instead, we will be using simply int in small letters. But here we are defined, we created a new data type with the help of type def. Okay, next one, This is another example. It is in continuation of our previous one. So we are creating a structure. The real and the imaginary are the members of the structure, and on creating a variable. So sorry, creating a data type complex, and for with this data type, they are declaring two variables a and b, okay, of type complex, and one more variable temp of type complex, and we are doing the various manipulation as per the demand. Okay, this is what denoted here. Okay, so we are able to do the various manipulation as per the demand. So here the complex is basically the data type. This was the data type due to the keyword prefixed as type def. Okay, so that's why this complex will become a separate individual data type. Okay, so this is the further continuation. So we are defining a function print by passing the structure. Yeah, actually, it is a structure member, and complex A is the data of user-defined variable complex. Okay, then it will be structure members can be accessed like a dot real or a dot image. So only the difference is in the data type. Here we are representing as complex. Since it is a user-defined structure, we are able to represent as like this. Okay, then in the main function, again we are using the data type as complex, and this complex will represent as like as normal data type by assigning the values as x equal to this much and y equal to this value. So we can print the value of x and y as like this. We can do the swap process. We can manipulate variables of user-defined data type as like or normal variables. Okay, so this is an output for the code. The next one is structures and functions. So these structures and functions are more related to one another. Okay, structures can be passed as an argument to the function. So structures can acts like a normal variable or normal argument. So where we are able to pass the structure as an argument to the function, the function can also return the structure. The function also can return the structure. Okay, so the next one example for this process here is, so here we have look here, we have creating already we have created a complex data type. So with this complex data type, we are defining a function called add. Okay, so for this function we are passing a structure variable of type complex x and y. Okay, then we are manipulating that structure variable of type complex here, like declaring another one variable as t, then t dot real equal to x dot real and y dot real plus y dot real, then imaginary as like that. Then we are returning the structure variable t. Okay, so it is a structure variable, but it is of type complex, like our integer, float, cap, as like that. We are using the variable t of type complex. So in the main function, we are declaring as like this. Then we are reading the value of the members as usual, like variable name dot member name, variable name dot member name. Then we are calling a function c equal to add of a comma b. This is the function call. So when calling this particular function, the control will come to this add function. Okay, the control will be moving to this add function. Then it will process the value a and b. Both are the structured variables, and it is received by the function called add, and further manipulation can happen as like this. Okay, so this is the way the structure can be passed as the parameter to the function. Okay, so We learned so far we learned about the basics of structure and how we can define declare and define the structure, how to access the members of the structure, how to create the variables of the structure. Okay, now let us get into the lab program, where we are supposed to store and display the information of the student using structure. So here we can create a structure with the name student. Okay, let us look into this example. So since we are going to store the information of the student, we are creating the structure called student with the member name as like that, roll number, name, age as like that. Okay, roll number is one of the member, name is another number, age is another member, then marks is another member. So these are the four members of the structure called student. Okay, these are the four members of the structure called student. So in this structure, these members can be accessed by creating the member variables. So here the member variable is not created here, but anyway it can be accessed. The members can be accessed with the help of member variable only. We can create the variables even outside the structures too. Okay, so like here we have declared a structure variable structure defined. Here we have defined a structure as like struct, then structure name. Within the structure name, we have mentioned the members of the structure. Okay, this is the way we have created the we have created the structure. Okay. Then the next one is main function, how we are able to invoke this structure. This is the second part. So as like our normal main function, we are reading inputs like enter the total number of students, and after reading the values using the scanf function, and we are creating the array variable as a member array variable for structure. So this is the statement where we are able to create the structure variable with the help of um, um, with the help of structure. So here struct student and then S of n. Enter the now student details means what we will be reading the details of the students one by one. So here the details of the student can be read for up to n number of students. So enter the student roll number and the student name, student age, and student marks. These are the members, right? Roll number is one of the member, name is another number, age is another number, mark is another number. So in order to access these member variables, we need to follow the format as variable name dot member name. Variable name dot member name. Since we have created the variable name array variable, this the variable is type array. So here S of n, so that it is represented as S of I. That means ith student's roll number, ith student name, ith student age, ith student marks, like that. So likewise, when it goes to the next iteration where I equal to 1, so it will read the details like roll number, name, age, and marks for the second students. Okay, so likewise the process will continue. Okay, so that's the way we are reading the value of the structure members, and also we are able to display the same in the same representation as like variable name dot member name, variable name dot member name, variable name dot member name, as like this. Okay, so this is the way we can use the structure. You can create and implement the structure with the help of structure variables, and the method of variable name and the member name for accessing the or initializing or manipulating the values of the structure members. Okay, so likewise the program for student information is created with the help of structure. Okay, this is a sample output. Okay, so likewise we can represent the details of various number of students as per the demand. Okay, so this is, it will print the roll number, name, age, and also his mark. So here roll number is of type integer, name of type character, age also integer, and the marks can be of float. So different date types of elements are represented within the structure. Then the next exercise is for generating payroll of employees using structures and pointers. So in this example, we are generating the payroll of the employees. So how we are able to generate the payroll of the employees means, as like our a previous example, we are supposed to define the structure. Here you are able to see that first we need to define a structure where type diff is the user defined data type, then struct emp is the structure name, then we are creating a data type with the name emp. It is of type structure. Its type is structure. Then inside the structure, we are creating the numbers like employee number, name, and also basic pay, allowance, and DD and NP. Okay, so these are the members of the structure. Okay, then the next one is and the net pay as well as the deductions also part of this salary computation, right? So that we are creating a structure with these members. Okay, then within a main function, we are creating a variable E, pointed variable E. It is an array variable of size 10. So it means that this particular variable is going to store the values of 10 employees. Okay, then this variable is of type emp. Then enter the number of employees. We are reading the top number of employees, and also we are repeating the process of reading the details of the employees as like using the for loop. For loop, we are repeating the process of reading the employees of the details of the employees. So here in this example, we are able to see a new function called malloc function. It is malloc is nothing but it is a dynamic memory allocation function. It is a library function for allocating the memory dynamically. So in case of array, we are able to store the element where the array size would be fixed. If we have declared an array of size 5, then its size is obviously fixed one. If you want to increase the size and decrease the size, it is not possible. So there may be a chances for wastage of memory if all the allocated memory is not utilized, and also there is a chances for shortage of memory if you want to store more elements than its size. So in order to overcome such drawbacks, we are using a function called malloc. This is the standard library function for allocating the memory dynamically. Okay, so it is a procedure in which the size of a data structure is changed during runtime. Okay, this particular malloc function is defined in a library called stdlib.h. Okay, so where we are having various other dynamic memory allocation related functions like malloc, cloc, free, and realloc. Okay, so basically malloc is a memory allocation based on the size. It will allocate the memory. So here it is the size of allocation. How much memory it should be allocated means it will allocate the size of the structure employee. So here the size of the structure consists of 4 different members. So according to the structure size, the memory will be allocated. Okay, so this is the way the structure will allocate the memory for storing the details of employees of n numbers. So we are reading the values as with the help of scanf statement, that is employee number and employee name we are reading, and we are allocating we are reading the values like basic pay, allowances, and the deductions as like. So here we are able to see E of I, then arrow, then V pay. That means structure variable dot member name. Member name here is the basic pay is the member name. Structure variable and dot is the member name. So here the member name is a basic pay, and also allowance, then deductions. With this, we are doing a computation part as like that: net pay equal to basic pay plus allowance plus deduction. So here the computation is done by invoking the values of the members. Okay, so this is the way the member can be manipulated with the help of structure. Okay, then here the MLOP is the dynamic memory allocation function. So that's the way we have allocated the memory based on the size of the structure, and we have accessed the member of the structure with the help of variable name dot member name, and we have manipulated those variable name with the computation like variable name dot member name equal to some combination of values like basic pay plus allowance plus deductions as like this. Okay, so then we are supposed to print the details of the same for each and every employee. So for employee I, we are printing the employee number, name, basic pay, allowance, deductions, and finally calculated net pay. So likewise, we are able to print the values of n number of employees using this for loop. So that's the way we are able to implement the structure for storing different elements of employees, and we can do the manipulation of with the help of structure by accessing the structure members through structure variables, and we can create the user defined data type called type def along with the dynamic memory allocation function MLOP. Okay, so this is the way the what's this? So this is the way the structure can be used. Okay, so thank you.